Well, thank you very much. It's great to be here. I have a bunch of slides to run through and not too much time, so I'm just going to kind of jam. My name is Andy Noorigian. One of the early employees of Hyperloop One. I've been here over a year and a half. Project director for our efforts here in the UAE and working with the RTA. And also was one of the team that came out to Dubai in September of last year to set up our operations, and I've been in Dubai ever since. So it's been a very exciting time for us. And I wanted to give you a little background on the company and what we're doing here. So this is our vision, to reinvent transportation, to eliminate the barriers of distance and time. We very much see ourselves as selling customers time, not so much transportation system. We want to give everybody back their time. Some specifics on the system itself, because some of this may be new. So it's a passenger or a cargo system. We can design it to essentially any size. And we put it in an enclosed structure. Right now we're looking at steel, and we remove the air from the tube. That reduces friction, lowers energy costs, and we have electromagnetic propulsion, which is at a fraction of what you could do for high-speed rail or even some metro systems, using passive magnetic levitation, and we envision it being fully autonomous. The low pressure, it's about the equivalent of flying at an altitude of 150,000 feet or so. So back to some of the earlier points on safety, a lot of questions are, well, if you're traveling in a vacuum, what's it going to feel like? What's it going to be? So it's essentially you're flying in an airplane on the ground. So it's going to be a pressure vessel up to 300 meters per second, which is about 1,100 kilometers an hour is our top speed. This is a conceptual rendering, actually, right underneath the Burj Khalifa. How we envision a portal, as we call it, instead of a station. We envision them being very much integrated into the environment, very much integrated into existing transportation systems. And what we see is very much a packetized system of transportation. So unlike existing rail or even airplane schedules, it's not a set time. It's on demand. Passengers show up, fully integrated, so you could be coming from an Uber from your house, and it's direct to destination. So you don't have to stop at all the intermediate stops, so that increases convenience, and it makes it a much better overall passenger experience. What that does, when you can start thinking about taking a Hyperloop versus existing modes of transportation over the medium distances that people have to do on a pretty regular basis, it saves a ton of time, and that opens up a lot of opportunity. And again, coming back to packetized direct-to-destination transportation, we see this as being extremely attractive in that it really, not only does it reduce time, but it allows for a much more personalized mode of transportation where you don't have to deal with the hassle of everything in between. Goods can get to where they need to be pretty much on demand, and same with people. And obviously, again, what that does is it frees up a ton of time as we're here in Dubai, and we look at driving to Abu Dhabi can take an hour and a half, maybe more if there's an accident. We're looking at 12-minute type travel time, so it's significant amounts of savings in terms of time and what that can do for people's lives. Historically, over the last 100, 200 years, changes in transportation have usually heralded significant leaps in GDP growth and opportunity. And we see right now there's been a tremendous amount of software innovation in the last 20 years or so, and now we're starting to see that really move over into the hardware side, and you're seeing it with aerospace, space, ground transportation, and it's really, we're just on the cusp of a revolution in transportation enabled by software, and we very much see ourselves as being able to be the backbone for all of that and help being enabling technology for all the change that's happening. And what you end up doing when you can really reduce travel time so significantly between cities is you create these virtual network areas, and so you can have people live in Washington, D.C. and work in New York daily, which is not something that's really feasible right now, and not very cost advantageous. We would see this being very low cost. And again, so we're not selling transportation, we're selling time. Think of all the opportunities that can happen when you can do the same commute in 1/10 of the time. It gives people opportunity to choose where they want to live, and they can commute when they want to commute when it's on demand. So it reduces cost of living, less wasted time in a car, easier access to attractions, cultural venues, wherever you want to get to, infrastructure. It really can increase convenience and help with people's lives, and I think that's very much a big focus area here in Dubai, smart Dubai, and improving the citizens' lives. I think that's something we can really tap into. And we see it very much as being kind of like the new broadband, the transportation broadband network. And if you go back again 20 years ago, and Cisco and Oracle and companies like that, they really were the backbone that unlocked a lot of what you're seeing now in the software markets, and we very much see Hyperloop as being able to do that. And so what the vision could be for when a Hyperloop system is installed here in Dubai, on-demand delivery for passengers, global supply chains. This is on a cargo side. We could have centralized warehouses, very easy loading, unloading. You remove trucks from the road, which makes for cleaner, more livable cities, less congestion, obviously. You increase the access to labor pools, and you can create mega manufacturing hubs. And I think one of the questions earlier was around investment in Dubai. And if you can really build an indigenous organic supply chain network here, think of all the different manufacturing opportunities that you could have, especially when you have DXB, DWC, Jebel Ali, the access you have to massive transportation modes. If you can really strengthen that backbone, that'd be fantastic. And what that allows you to do is have a super efficient supply chain in country. Just a little illustration. So reduce congestion. So our baseline of capacity is we can do up to about 20,000 passengers peak hour one way, depending on configurations, depending on departure rates. There's a lot of variability within that, but that can obviously take a lot of cars off the road. We can go at grade, above grade, on underground, and our footprint is pretty small. It's just a pylon footprint. We'll have some safety barriers around it, but it's makes for efficient land use. And very high energy efficiency. I don't want to give too much of the specifics, but fractions of what existing modes of transportation are on a passenger kilometer basis. This is an example of future state. We just did the Hyperloop Global Challenge in Washington D.C. We're segmenting this out into smaller, more digestible networks, but eventually these are the types of things we're thinking of. And now here's a more relevant one for the GCC. This is a network that doesn't currently exist, obviously, via rail or anything else, and by road it's very long, and you can do air travel to certain of these cities, but to be able to have this kind of regional connectivity where it doesn't currently exist, the opportunities of what this could open up for commercial, also just for where people want to live and work, are tremendous. And no city pair is more than an hour apart in this scenario. So it's very attractive. We're having good discussions with people throughout the region. And I think there is clearly a need and there is clearly a demand for a system like this in the region. This global future state. So there was a question on cost earlier, actually, that came up, and we use a model that we call a should cost model. So it's basically designing to a target cost that our engineers come up with from a bottoms up basis, and that leads us to drive a lot of innovations internally, because we can actually very quickly iterate and be very tied in with our test and development groups. So low-cost tube structures, we're doing reduced mass steel there. Our linear electric motor has all been custom designed, and we're actually manufacturing it in-house. passive maglev, so the new track, new guidance systems, that is all being done in-house. A lot of our power electronics, VFDs, thyristor switches, a lot of that we're doing in-house. So a lot of these components actually on a standalone basis could probably be products, and we're doing that all on our own. And then the control and safety platform also, some of that we're using vendors for, but ultimately we see that being fully in-house as well. And it takes a lot of people to do this. When I started the company, we were less than 50 employees. Now we're over 300, and we're targeting 500 by the end of the year. And out of that 500, we are looking to add here in the UAE, and now that we have an office open. As I said earlier, we can have a suite of different solutions. Obviously, there's CapEx implications as you go up the chain here on a bigger tube and a bigger pod. But what we're trying to do is optimize the design where you can get the most into one tube structure. So this is a little bit of how we think about future state and where the integration side of things can be. If you have fully packetized travel, having a very large train-like structure that fits 100 people doesn't really make it very easy to integrate with something like Uber. You still don't have seamless connections. So what we see is actually a more modularized packet type system where you could still have 100 person larger train type structure, but you would have smaller units within that can be fully autonomous and separate on their own, and they join together for the backbone transit. And so that's one area where we think there could be a lot of innovation that fully integrates with a lot of the autonomous and systems that are out there. Again, direct and on demand, direct destination, on demand from when a passenger shows up. High capacity, our target rate is 10-second headways. Obviously, that's a safety case we have to prove and work with the regulators to do that, but that's what we're targeting. Fast, reliable, safe. It's, again, 300 meters per second target speed. Fully integrated, controlled system, and fully autonomous. So on the cost question again, I would say our models stack up very well compared to high-speed rail and Japanese maglev systems. A part of that, or a big part of that, is actually the vacuum itself, because we don't have to have powered track the whole way, which is a very significant driver of cost. So it's just some high-level sample cost numbers versus high-speed rail. I'm going to skip through those. Very efficient, very quiet. Again, the energy cost on a passenger kilometer basis is significantly less than high-speed rail. No direct emissions. We are powered off the grid right now, though in the future. One of the things we're looking at here in Dubai is could you actually use solar on the tube structure itself. It is something that can be done, and we're looking at it. It's not our base case right now, but we could have zero grid electricity in the future as well. Just transportation markets, I think we all know that. So we look at things on a use case basis. And sorry if I'm rushing here, I only have a few minutes to get through everything. We break out our use cases by type of transport, so whether it's passenger or cargo, and over the distances we're looking at, and how we match up. There's different engineering characteristics that go into each of these, and how we treat them. The base technology is pretty much the same, and the cost varies a little bit here and there, but there are differences in the engineering and the way we would look at different solutions. The important thing, though, is we want everything to be able to scale and be fully integrated, so you don't want to just start with a metro or airport connector and have it just, that's it, a 30-kilometer route. We don't want it to be like Shanghai Maglev. We want it to be able to scale to an entire network. Number of projects in place, and this is it's a little dated now. There are some additional ones in here. We've had a team in India last week. We continue to have interest all over Europe and the US, Australia, and GCC, of course. GCC has been a great opportunity and great set of customers here. Demand around the world. And here's some of what we've been looking at in UAE. FS links, so this would be Helsinki, Stockholm. Melbourne, Sydney, I just mentioned, Australia. LA, Long Beach, this would be a specific port solution to help increase the capacity of the port and also reduce congestion. I'll just run through a little bit on the company itself. So this is dated now too, we're actually pushing 300. Most of our backgrounds tend to be in aerospace, space and aerospace. We're starting to beef up a lot more around the rail and the contracting side. Our management team, led by Rob, who used to be the president of Cisco, and Shervin, early investor in Uber, and Josh Geigel is our co-president, our co-founder and president of engineering, and he used to work with Elon at SpaceX on the Falcon engines. Top tier investors, so we're kicking off a C round now. Notably here in Dubai, DP World is a big investor, and His Excellency Sultan, he's on the board. He's been an unbelievably valuable asset to the company with his knowledge and what he brings to the table. And we've developed a world-class partner network as we go out and we look to build the first Hyperloop. Here in Dubai, we've been working with Parsons, DP World, McKinsey, KPMG, so it's been a good ride. And just I'll wrap up in a minute here with just some pictures of what we're working on here. You can actually see this is a vacuum chamber where we test different levitation systems in LA. This is some welding on some of the tubes that are going out into DevLoop. This is the vacuum system right before it got installed, and in the lower right-hand corner is the frame for the pod that's going into DevLoop. DevLoop is where we're doing the first full-scale test in the next couple weeks. This was our propulsion test about a year ago, where we proved the underlying propulsion technology. Tubes being prepped for the desert. I think I do have a good shot here of the actual. So in about 3 weeks, stay tuned. The full system will be up and running, and we'll have some announcements around that. So a lot of exciting things going on. And that's all I have for today. Thank you very much for having me.
Andy, thank you very much. I'm sure there might be questions here. I have a personal question. How much would it cost a commuter to travel from Abu Dhabi to Dubai? One way and round trip.
That's a great question. And so we've been working with RTA very closely on the demand modeling, and obviously a lot of it gets influenced by, the ridership gets influenced by the fare. One of the most important things we want is it to be a system for everybody. We don't want it to just be super expensive. And so our base assumptions are pricing it similar to what a metro fare would be.
I'm sure that's a key element for everybody, because everybody is excited for sure. Are there any questions for Andy? We can take one before we close. Can we have the microphone here, please?
Hello. Yeah.
Oh, there's a question there. So I'll come back to you, sir.
Yeah.
Let's go ahead.
This is Jayant Rangari from Eurostar. I would like to know from Andy, what would be the G-forces applicable on the passengers traveling through this Hyperloop?
So we can actually flex that however we want. Our base assumption is 0.3 on the acceleration and 0.2 on the deceleration. That gives you about 15 kilometers required to hit top speed if you do it that way.
Okay, thank you.
The next question.
You mentioned two ways of getting your levitation. You mentioned the maglev and the positive magnetic levitation. Which one are you using, and what's the difference between the two?
So that may have been, I may have misspoken a little bit there. We're just using passive maglev, and the difference is, well, so the way the system actually works is you have the stator down the center, and once you power up the system, it creates a current, a repelling current, and it just pushes the tube, pushes the pod down the tube. You do still have some aero drag in there, so what ends up happening is you accelerate up to your top speed and then you start to coast. So about 10 to 15% of your entire track is powered, and as you coast, you lose speed and you'll have booster stations along the way. That's the base system that we're envisioning.
All right, Andy, thank you very much for a wonderful presentation.
Thank you very much.